Okay, welcome to Trigonometry's section 3.5, talking about double angles and half angle identities today. All right, so what we're going to begin to look at is where these identities come from. So I'm going to do a little proof of each one of these. I'm going to start by proving, doing the derivation of sine 2x. Okay, so this is the sine of twice an angle is twice the product of the sine x and cosine x. Okay, so let's do a derivation of this. The derivation is actually very simple. So mathematicians always kind of look for clever ways to develop more ideas. So what we're going to do is we're going to write 2x as x plus x. That allows us to use the sign of the sum identities that we learned, which just says you take the sine of the first angle, which is x, multiply by the cosine of the second angle, which is also x, use the same sign, and then do it backwards. Do the cosine of the first angle, which is x, times the sine of the second angle, which is also x. Now notice when you look at this, these are like terms. You have a sine, cosine, and a cosine sine, which are the same term. So that means there's a total of two of those when you combine those like terms. So you get that that's equal to 2 sine x cosine x. So that develops that identity for us then. Okay, that's a very simple derivation. The second one I'd like to derive is the cosine of 2x. Its derivation is quite similar. We're going to start by saying cosine of 2x is equal to the cosine of x plus x. So we're going to use a similar derivation on that. Let me rewrite that just a second here. All right, so what we're going to get is, again, starting by saying, not sine, what's wrong with me? Cosine. Okay, here we go. Now I'm thinking. Cosine of x plus x. So we have a cosine sum identity. We have two angles, the first and second. So that's the identity for cosine sum goes cosine of first times cosine of second. We'll use a different sign. And then sine of first times the sine of the second. Okay, so notice that's going to give you cosine squared x minus sine squared x when you multiply those two together. And then that pretty well develops that idea then. Okay. Now we have a couple of other things that we can do. We can take this in two directions now. So if I was to start with the cosine of 2x, we now know that that's equal to the cosine squared x minus sine squared x. Well, I can utilize an identity that I know, and I can rearrange this like this. So I can replace the sine squared x with what it's equal to. It's equal to 1 minus cosine squared x. And that's just taking the identity sine squared x plus cosine squared x equals 1. And then if I was to solve this for the sine, I get 1 minus cosine. So then if I work out the details on this, I get cosine squared x minus 1 plus cosine squared x, and that gives 2 cosine squared x minus 1. So that gives that second form of the identity then. Okay. Now we can also get this third form of the identity in a similar way. We just start with cosine of 2x, again, is equal to cosine squared x minus sine squared x. So we can do a very simple substitution. Okay, looking at this identity, sine squared x equals 1, sine squared x plus cosine squared x equals 1. I can replace the cosine with what it's equal to in that identity. So I get, this gets replaced with 1 minus sine squared x. Bring down the minus sine squared x. These are like terms, so we have a sine and a sine, so we have 1 minus 2 sine squared x. So what we have is we have these three different versions of the cosine of 2x. That's where they all come from. Okay? Now the tangent identity, I'll go ahead and take the time to show you where the tangent identity comes from too. by a similar argument, we can say the tangent of 2x is equal to the tangent of x plus x, like that. Let me write that a little better. Okay, so we have tangent of x plus x, and then the identity that we have for this goes like this. Okay, these are the two angles, the first and second. So the tangent sum identity goes like this. Tangent of first angle plus tangent of second angle all over 1 minus, okay, then it's the product of these. The tangent of the first angle times the tangent of the second angle. So when you put that together, notice that the numerator, those are like terms, so that's 2 tangent x. And the denominator, you have a tangent times a tangent, so that's 1 minus tangent squared x. Okay, so notice that have now derived that identity also. Okay, so the derivations of these three trig identities are actually all very easy to do. Something I do all the time. If I forget the identities, it's just as fast to derive in as it is to look them up. That's what you need to learn how to do. Okay, so let's see what's kind of going on this thing here. I got this guy's face here. I don't know who this guy is, but maybe this trig expression will help us to figure this out. So we have the sine of b over the tangent of b. Well, let's simplify this and see what we get. So I'm going to write this as the sine of b over 1 times 1 over the tangent of b. Okay, you can break fractions apart like this. I'm going to leave the sine of b alone. Then I'm going to replace 1 over tangent with what it's equal to. That's equal to the cotangent of b. Okay, then what I'm going to do is I'm going to replace this with what it's equal to. Now we'll see what comes out of this. So we get sine of the angle b over 1. The cotangent is the cosine of b over the sine of b. So what happens is, of course, the sines divide out to 1. And it looks like we're left with cosine of b. So what does that have to do with this? Well, I think this is Bill Cosby. Ha ha ha. I didn't come up with this. I don't have enough time on my hands to come up with stuff like this. So hey, 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 it's Bill Cosby. All right, I saw that on the internet. I thought it was kind of funny. All right, so let me show you how this stuff works out, double angle identities. I'm going to give you an example of how they work. Now, first of all, if we were to look at just finding the sine of 300 degrees, the simplest way to do this would be just to go directly to the unit circle. You know that you're in quadrant 4, and basically a 300 degree angle is counterclockwise, goes up to this point, and that point on the unit circle is going to be the point, has an x value of 1/2, and it has a y value of negative square root of 3 over 2. And of course the sine is the y value, so that means the sine of 300 degrees would be equal to negative square root of 3 over 2 if you did that. Okay. Now what we're going to do is we're going to do this in a totally different way. I'm going to illustrate how this works if you're using a double angle identity. So the double angle identity for sine goes like this. We have the sine of 2x is equal to 2 times the sine of x times the cosine of x. So if we're going to use this identity, what we do is we write 300 degrees as 2 times 150 degrees. So we're going to find an angle that we double. And I want to stress, if you're using this identity, the right side of this identity, x is not going to be 300, it's going to be 150. So really what we're working out according to this identity is 2 sine x cosine x. So that's going to be 2 times the sine of 150 degrees times the cosine of 150 degrees. So let's go to the unit circle and let's crunch this out then. So we know that we're in quadrant 2. And 150 degrees is counterclockwise up to this point on the unit circle. And that point on the unit circle has a x value of negative square root of 3 over 2, and it has a y value of 1/2. Okay, so if we do the sine of 150, the sine of 150 degrees is going to be 1/2. The cosine of 150 degrees is going to be the x value, so it's going to be that. So now if we crunch this out, we're going to get 2 times the sine being a half. Cosine is negative square root of 3 over 2. Notice that the 2's divide out, and what you're going to be left with is negative square root of 3 over 2. You get the same answer. Now the double angle identity, you typically use it more for solving equations and proving identities and rewriting expressions than you do finding the values of angles. But this is a good way to show you how this identity works and why it works. Okay, so let's go to the next page, and I'll do the same illustration with a cosine. Okay, first of all, if we were to just convert this to degrees, we would do this, of course. And 180 over 3 is 60 degrees. And then this would be 5 times 60, so it would be 300 degrees. So we're really looking at the cosine of 300 degrees on this problem. Now, if we were going to go to the unit circle again, what we would find on this basically is this. Let me use my coordinate system and make this a little neater. Okay, so I'm starting to get this figured out. Look at that, isn't that sharp? Okay, so what we have going on this basically is 300 degrees. You know that you're in quadrant 4, and where you are is you're at this angle right here. Okay, and that angle right there has a x value of a half, and it has a y value of negative square root of 3 over 2. So that would mean the cosine of 300 degrees would be the x value. So that means that would be equal to a value of 1/2. So that would be the solution to the problem. Now we can also look at this with the cosine double angle identity, and I'm going to just use this form. So the cosine of 2x is equal to cosine squared x minus sine squared x. So in order to use this identity, if we have the cosine of 300 degrees, we want to write this as the cosine of twice 150 degrees. Okay, then when we put this together in this identity, the x is not 300, it's what's being doubled. So that's 150 degrees, so you're going to put this together like this then. So you're going to have the cosine of 2 times 150 degrees is going to be equal to the cosine squared of 150 degrees, which will work out, minus the sine squared of 150 degrees, and we should get the same answer. We should get a half if we work this out. So again, let's consider a unit circle, just kind of look at a diagram this time. And what we're going to look at is, we know that we're in quadrant 2. We're counterclockwise. So we would be at this angle on the unit circle, which has an x value of negative square root of 3 over 2, and it has a y value of a half. So when we work this out, the cosine of 150 is going to be negative square root of 3 over 2. So I'm just going to write that as negative square root of 3 over 2 squared. Then the sine of 150 degrees is the y value, so that's a half. So I'm going to write this as 1/2 to the second. So if I work this out, I'm going to have negative root 3 over 2 times itself. You can do this in your head if you want to, of course. And then I'm going to take a half times itself. So this is going to give square root of 9 over 4 minus 1 over 4. So that's 3 over 4 minus 1/4, which is 2/4. And of course that reduces down to 1/2. So you do get exactly the same answer like that. All right, so that's how that identity can be used. Any of the 3 forms of the cosine double angle identity would give the same result. Okay, so let's go down. Let's do work a little bit with a tangent now. So first of all, on this problem, we know that we're more than one rotation around the circle. So if I subtract 360 from it, I get 120 degrees. So if we looked at a unit circle diagram on this problem, looks like we would have an angle that looks like this. First of all, we would be in quadrant 2, okay, but we would have an extra rotation. So one rotation would be 360, then we'd have to go 120 more, which would actually take you to that point on the unit circle. And that point on the unit circle has an x value of -1/2 and a y value of square root of 3 over 2. And see, I always figure that out a certain way. The y value is as big as possible because it's up as high as possible. That's why I know the y value has a square root of 3 in it. And then the x value is as small as possible, so that's why I know it has a 1 in it. That's how I figure that out. That's a really handy thing to catch on to. So what you would do now is, since the tangent is y over x, we would be taking the y value, which is square root of 3 over 2, and we would be dividing it by the x value. Of course, we know that we divide fractions by multiplying by the reciprocal. Okay, it looks like the 2's would cross out. Looks like you would have a negative answer, so you just have negative square root of 3 over 1, or just negative square root of 3. So that's the answer just by a standard unit circle approach. Okay, now the next thing I'm going to do is I'm going to use the double angle identity. So the double angle identity for a tangent goes like this. Tangent of 2x is equal to 2 tangent x all over 1 minus tangent squared x. Okay, so what we're going to do is we're going to rewrite the tangent of 480 degrees. We're going to write it as doubling. So if we take 480 divided by 2, we get 2 times 240 degrees. Okay. Then what we do is, in this identity, see that x is not 480, it's 240. It's what you're doubling. Okay. So what we're going to do is we're going to plug into the identity. So we're going to have 2 times, what in the world is that thing doing? Stop it, please. Okay, we've got 2 times the tangent of 240 degrees all over 1 minus tangent of 240 degrees squared. So we're going to work that expression out when we do this then. So we're going to go to a unit circle again. So I'm going to draw a unit circle diagram here at the side. 240 degrees is located in quadrant 3. And if you were to look at this angle, it would be this angle on the unit circle. Okay, just a little bit below 270. And then that point, notice the x value is smaller than these two x values, so that means that's -1/2. The y value is down further than the other one, so that's got to be the square root of 3 over 2. Okay, so if we did the tangent of 240 degrees, that's going to be y over x. So it's -√3 over 2 divided by -1/2. Of course, that's positive. So you'd have square root of 3 over 2 times 2 over 1 with the 2's crossing out. So you would end up having square root of 3 on that. Okay. Now we're not done with the problem because we got to go work these things out now. Okay, so we just know that the tangent of 240 is the square root of 3. So when we do this, then we're going to have 2 times the square root of 3 over 1 minus the square root of 3 squared. Now we need to just work out arithmetic. So that's 2 radical 3 in the numerator. That's 1 minus 3 in the denominator. So that's 2 radical 3 over -2. Of course, the 2's cross out. That's where the negative comes in. So you would have the same answer, negative square root of 3. Certainly is a lot easier to just go immediately to the unit circle, but the point of this is to show you how this works. Okay, now we're going to work out a few things just kind of in reverse. So this number 5 clearly is the backside of the tangent double angle identity. So the tangent double angle identity goes like this. Tangent of 2x equals 2 tangent of x over 1 minus tangent squared x. So if you look at this angle, that's what x is. Okay, so that means we have to double this angle when we get the right side of this. It's got exactly the same structure, so that means that what this problem is really mathematically equivalent to is the tangent of 2 times 30 degrees. Well, that's really equal to the tangent of 60 degrees. And then we could go to a unit circle and we could easily write that out. You can even use a right triangle on this if you want to. I think just for variety, I'm going to do a right triangle on this just for something different. So let's draw a 60-degree triangle. And then the 30-60 triangle goes like this. The sides are 1, square root of 3, and 2. The tangent would be, if you want to look at it as side opposite over adjacent, the side opposite is going to be root 3. And then the side adjacent is going to be 1. So you would have square root of 3 over 1, or just square root of 3. Of course, you could also look this up on a unit circle. This point on the unit circle really is the point 1/2 square root of 3 over 2, and it still works out the same way if you do y over x. So you can do it that way. Okay, next problem. This one clearly is cosine identity. So we have a cosine double angle identity that goes like this. Cosine of 2x is equal to 2 cosine squared x minus 1. So in this problem, the 75 degrees is what x is. It's not what 2x is. So what you would do is you would realize that this would be the same thing as the cosine of double that angle. So it would be the cosine of 2 times 75. So that's equal to the cosine of 150 degrees. And we can analyze that on a unit circle like we've been doing then. Okay, so on a unit circle, 150 degrees, of course, is in quadrant 2. Okay, and it will be equal to this angle. It will be this point on the unit circle. And that point on the unit circle, x is as far to the left as possible. That's why I know that that's negative square root of 3 over 2. Y is not as high up as the other 2 points. So that's why I know that's positive square root of 2. And then a cosine is just a x value. So that means the answer automatically on this problem is going to be negative square root of 3 over 2, like that. So you're just identifying that you're doing kind of the back side of that identity. And that's how that goes. Okay, so that'll kind of give you some idea of how that identity works. The next thing I want to look at a little bit is how the half angle identities work and kind of where they come from. I'm not going to do a derivation of these things, but we do have these forms right here. So the first form is, this is the sine of x over 2. That's just saying the sine of an angle divided by 2, or half the angle. Then the cosine has a slight difference. These two identities have exactly the same structure. The only difference being this is 1 minus cosine and that's 1 plus cosine, like that. Then you want to notice on there, this tangent identity, where it comes from. It's actually pretty easy to see a derivation of this. So I'm going to do a quick little derivation of that. So if you remember the sine and cosine identity, it's pretty easy to find the other one. So the tangent of x over 2 would just be equal to the sine of x over 2 all over the cosine of x over 2. So if you put this together, you would have plus or minus square root of 1 minus cosine x over 2 for the sine over plus or minus 1 plus cosine x over 2. And one thing that you can see on this, I think, okay, is those things cross out. So what you're left with is just plus or minus 1 minus cosine x over 1 plus cosine x. So it's actually very easy to derive those two things right there. The derivation of these two is a little bit more complicated, but typically, one thing that you might want to make a note of is on the tangent identity, there's 3 versions. And this one right here is typically the best one to use. So you're going to see I generally use this identity more than I do that identity or that identity, just because it's easier to deal with. doesn't have a radical, and it just has a sign in the denominator, so I use that more often than the other two. Okay, well, you're going to notice they have a plus or minus sign. Now, and again, this is not really a misprint. If you look at this, these angles, this is the way this works. Okay, what goes here, remember, you're doing half of that angle. This is a sine of half of that angle, all right? Same thing here. This is cosine of half of that angle. So that is not a misprint. So the question on this is this a positive or negative answer? Well, okay, first of all, 111 degrees is in quadrant 2, and the sine is positive in quadrant 2, so that would be a positive answer. So the sine of theta is positive in quadrant 2. Okay, the next one, cosine. Well, this would be negative because the cosine of an angle is negative if you're in quadrant 2 or quadrant 3. Okay, then the next problem, now this one I think is a typo. I think that these angles right here are wrong. I'm pretty sure that this angle is incorrect. I can tell by looking it's incorrect. So the idea is it would have to go like this. This angle right here has to be doubled to get this angle, just like doubling that gives that. So if you were to double that, you would end up getting this. So that angle was written wrong in there. That angle should be negative 3 pi over 5, okay, is what that should be. So you might want to scribble that out and just realize that that's supposed to be negative 3 pi over 5, okay? Well, the thing on this is if you look at this angle right here, looking at that angle, if you change the pi to 180 degrees, and do this, of course, that's going to give negative 3 times 180 over 10 is 18, and then 3 times that is negative 54. So this angle is a quadrant 4 angle. It's a clockwise angle since it's negative, and remember the tangent is negative in quadrants 3 and quadrants 4. Okay, so the tangent of an angle theta is negative if theta is in quadrant 2 or quadrant 4. So that would have a negative answer. So one of the things you got to do with this identity is you got to figure out if your answer is negative or positive. So you must do that. Okay, now I'm going to go through and utilize these identities. So what we have for this one is we have the sine of x over 2. The identity is it's equal to plus or minus 1 minus cosine x all over 2. So I am just pulling that out of this list of identities, 1 minus cosine over 2, like that. All right, so it turns out that we can find the exact answer for this angle. So what we're going to do, if we're going to use the half angle identity, now you got to figure out what angle you would divide by 2 that would give you 22.5. So if we take 22.5 and we double it, we're going to get 45 degrees. So we start this problem by saying this is the sine of 22.5 degrees can be written as the same thing as the sine of 45 degrees over 2. All right? Now, in this thing, notice that x is 45. X is not 22.5, it's 45. So we're going to write this as plus or minus square root of 1 minus the cosine of 45 degrees all over 2. Okay, like that. Now what we need to do is figure out the cosine of 45 degrees, but the other thing is this is a quadrant 1 angle. Therefore, we would conclude that the answer to this problem is positive. Okay, just because of that identity. So we would have positive square root, and then if we do the cosine on the unit circle, the cosine of 45 is square root of 2 over 2, and that's all over 2. Okay, so you have that. Remember, on a unit circle, the 45 degree angle is the point square root of 2 over 2, square root of 2 over 2. That's the point on the unit circle. All right, now we have to clean this up a little bit. So what you do on problems like this is you have a complex fraction. So you can go under the radical, and you can multiply the top by 2, and you can multiply the bottom by 2. You're not changing anything. You're going under that radical and just multiplying the fraction by 1 in a sense. So you do that. So then when we put this together, just kind of think how the distributive property goes. You're going to have the square root of 2 times 1 is 2. And then when you do these two things, multiplying them, the 2's are going to cross out, leaving you square root of 2. Then the denominator is 2 times 2, so that's 4. And then the other thing that we can do on this problem is you can do this in your head. If you have a square root of an entire fraction, you can just do the top and bottom separately. So the square root of 4 is 2, so we would get as an answer 2 square root of 2 minus radical 2 all over 2. That is a valid answer to that problem. That's the way that you see that written most often. You oftentimes see this written as 1/2 times the square root of 2 minus square root of 2. There's a few other ways that you'll see that. So you can write it that way. You can write it that way. Those are valid answers. Now, on the calculator, it's also kind of worth showing you on this problem how this problem can be checked and analyzed with a graphing calculator. So I'm going to turn my calculator on. And what I'm going to do is put my calculator in degree mode. Okay, so let's get that in degree mode. And let's enter it like this. Okay, so we could do the sine of 22.5. And that'll give us decimal values. Now, if I take my answer, I put my answer in actually like this. I have to go square root, then I have to do, in that parenthesis, 2 minus, and then another square root of 2, close the parentheses and double up on that parenthesis, and then divide that by 2, and you get the same thing. So that's how you're going to put that in your calculator to check and verify. So typically you can write the answer one of two ways. Okay, let's do a cosine. So on the next problem, the identity for cosine of half the angle, or cosine of x over 2, is plus or minus the square root of 1 plus cosine x all over 2. Like that. So it's the same thing as the sine identity, except it's got a plus in it. So that's the way that works out. Okay, so again, what we have to do is we have to figure out what angle gets cut in half like that. So we don't use 165. What we have to do in this problem is we have to double this angle first. So if we double that angle, I think we're going to get 330 degrees if we work that out then. So 330 degrees is an angle that we can utilize on the unit circle. So we're going to start by writing this as the cosine of 330 degrees over 2. And then that's what's going to get plugged in for x in our identity. Don't plug 165 in, plug 330 in. That's a common mistake. Okay, first of all, we have a quadrant 2 angle. The cosine of a quadrant 2 angle is negative. So we do have a negative answer, so we're going to use that negative. And then we're going to go 1 plus cosine of 330 degrees all over 2 by utilizing this identity. Quadrant 2, remember, pay attention to the 165 when you determine if it's positive or negative, because that's what we're doing, is finding the cosine of a quadrant 2 angle. Okay, now what we can do is we can go to our unit circle and we can look up a 330 degree angle if we want to. Okay, so a 330 degree angle is actually in quadrant 4, and it's this point right here. That point on the unit circle, the x value is over as far as possible, so that's square root of 3 over 2. The y value is down as little as possible, so that's negative 1/2. That's the way I think of that. So that means that the cosine of 330 is going to be equal to that x value. So when we plug this in our next step, we're going to have negative square root of 1 plus, and we're going to, the cosine of 330 is square root of 3 over 2, all over 2. Then what we're going to do is we have a complex fraction, so we have to get rid of it. So we're going to go under the radical, multiply the numerator by 2 and the denominator by 2 like that. Okay, and when we do that, it's going to go like this. Okay, we're going to do 2 times 1, which is 2. Then when we multiply these things together, those cross out, leaving radical 3. And then 2 times 2 is 4. So we have that. Okay, so now I'm going to just break it up into the numerator, which is 2 plus root 3. And then the denominator is square root of 4. So we get an answer negative square root of 2 plus square root of 3 all over 2. And that's it. You can have that radical under a radical. You can also write the answer as negative 1/2 times the square root of 2 plus root 3. I kind of prefer the first way, but either of these two answers are mathematically correct. Now again, you could do a quick check on your calculator. You could go in degree mode, cosine of 165, which gives you this. Notice it gives the negative answer like we predicted. And then you would put in a negative, then you would put in radical, then you'd have to put 2 plus square root of 3, like that, doubling up on the parentheses, and then divide by 2, and it'll give exactly the same thing. So this problem is 100% checkable on a calculator. Okay, let's do on the next page, let's go ahead and do a tangent identity. So for the tangent, we have this identity. The tangent of 2x, and we can use, I'm going to go back and show you what you want to do. You want to be smart in the way you do tangents, seriously. Okay, I'm going to go back just to show you on here. This is the one you want to use, 1 minus cosine over sine. It's so much easier. Don't use any of the other two. 1 minus cosine over sine. If you use the other two forms, it'll work, but it's just the algebra is harder than it needs to be. Don't waste your time. Just keep it simple. Okay? All right. So first of all, just a couple of things in this problem. So let's go ahead and convert this over and find what we have here. So if I was to go through, and if I do 180 divided by 8, that's 22.5. Okay, so that crosses out to give 22.5. And then 22.5 times 7 is 157.5. So this is a 157.5 degree angle. So we're going to utilize the tangent identity for 157.5 degrees. Okay, so again, when we do this, now what in the world is this thing doing? It's erasing everything I just typed. Why in the world is it doing this? I swear this computer has a brain of its own. It just does whatever the hell it wants to do. So let me pause on this thing for a second. Okay, what it is doing, I have no clue. It's kind of like you press a button erroneously. You don't know what you're pushing, and it just messes everything up. So please don't erase what I just wrote. It's 157.5. Thank you. Now we have tangent of 157.5, and we're going to double that angle. So at the side of my paper, you can use your calculator if you want to. We're going to double that angle, and that's going to fall on a unit circle as 315 degrees. So we're going to write this as the tangent of 315 degrees divided by 2. So in our identity, x is going to be 315. Okay, it's the angle that is being cut in half. Now I did notice I put a mistake on here. I just saw that. This should be the tangent of x over 2, so I apologize for that. Okay, so in the identity, we're going to go, notice there's no plus or minus in there too, which is kind of good. So it's 1 minus cosine of 315 degrees over 2. So we just need to look at our unit circle and need to figure out what's going on at 315. Okay, so we're halfway in the middle. We're basically at this point on the unit circle. That's where 315 degrees is. That has an x value of positive square root of 2 over 2 and a y value of negative square root of 2 over 2 like that. So if we do the tangent of 315 degrees, that's going to be y over x. So you can do that in your head. That's going to be -1. Okay, so what we do then to finish this up, it's actually very simple, is we just know that the cosine of, let's see, what in the world did I do? I made another stupid mistake here. This is sine down here, like this. I need to be paying attention to what I'm doing here. God, what's wrong with me? So sine of 315, okay, like that. That's the identity we're using. Okay, so here's what we do in this problem then. So we need to do, the cosine of 315 is this. So that is 1 minus square root of 2 over 2. Now the sine of 315 is the y value. So we're going to plug that in as negative square root of 2 over 2. Okay, now the reason I like to use this identity is rationalizing the denominator is like a whole lot easier. So there's a couple of ways to do this, I guess. One thing that you could do is if you wanted to get rid of this whole thing, it might make a lot of sense to just try this. Now, there are different approaches on here. So what I'm going to do is I'm going to be kind of sneaky about this, and I'm going to multiply the bottom. I could multiply it by the reciprocal if I wanted to, just so it would turn to 1. So let's just multiply this by -2 over root 2. That's kind of sneaky. But that way, it kind of gets rid of the denominator. So whatever we do at the bottom, we got to do the same thing at the top. Let's do it this way just for variety, but there's different ways to do it. So that means that the numerator, you're going to have -2 over root 2. And then this piece right here is going to be plus 2 root 2 over 2 root 2, which is going to give you a 1, it looks like. Okay, then the bottom is going to give you 2 root 2 over 2 root 2, which is 1. So what I end up getting is I get -2 over root 2 plus 1 all over 1. And really all I got to do on this thing now is just rationalize that denominator and get a common denominator to get this worked out. So there's a couple of approaches you could take from here. You could say this is -2 over root 2 plus root 2 over root 2 when you get a common denominator. So that is equal to -2 plus root 2 over root 2. Then you could rationalize that denominator. And I think I'll go back and show you a slightly different way to do this in just a minute. So now what I could do is I could multiply the top and bottom by the square root of 2. So I would get this as a final answer. I'm going to have -2 root 2 plus the square root of 4, so that's 2 all over 2. And then I could factor a 2 out, or I could just break this up into 2 parts, and then I'll have this. I thought I was going to have an easier way of doing this, but now that I think of it, it probably would have been better if I would have done this a different way. So let's just write that as -2 over root 2 plus 2 over 2. Everything will cross out. The 2's cross out, so you just end up with an answer of -root 2 plus 1. Generally, we write that as 1 minus the square root of 2, like that. Okay? So, I'm going to go back and show you a different... Okay. All right, now I'm going to erase this and show you a different way to do this. I don't know if it's going to be any simpler or not, but it might be. So that was a little bit different way of doing that. So I'm going to erase this and just kind of pick up from this point right here. And I'm going to look at this in a slightly different way that you might be a little bit more familiar with. And it may be about the same level of complexity, or it may be simpler. So let's go ahead and just re-crunch this out just for something different. Okay, so what we're going to do at this stage, remember what the identity says, is that this is going to be 1 minus cosine of 315 all over sine of 315, utilizing this identity right here. Okay, so the cosine is the x value that I got in yellow, so that's going to be 1 minus square root of 2 over 2. The sine is going to be the y value. So let's do this. Let's do this in a way that you're probably a little bit more familiar with seeing me do. So we have a complex fraction. So I'm going to multiply the top and the bottom by 2 over 1 to eliminate that. So if I do that, I'd have 2 times 1 is 2. Okay, and then these multiply together, crossing out the 2's to give you this. And then the denominator, that crosses out, leaving negative square root of 2 like that. Okay, now let's rationalize this denominator like this. Okay, so let's multiply by, actually let's get rid of that negative also. So let's multiply by negative root 2 over negative root 2. That way the denominator will have a positive number in it, which is preferable. So let's see if this works out a little easier. So what we're going to have is that times that is negative 2 root 2. Okay, this times this is a positive square root of 4, which is 2. Then the denominator is a positive square root of 4. So I kind of like the way this works out. So that's negative root 2 plus 2 all over 2. Okay, I'm going to write this as negative 2 root 2 over 2 plus 2 over 2 like I did before. So that's 1. And then this crosses out, leaving negative root 2. So you would get the same answer. Okay, so our final answer to this problem is this. Maybe just as easy to do it that way. I just wanted to do something a little different. Okay, number 14 and 15 are very similar problems. And what we're doing on this one is I give you a couple of pieces of information. You're given cosine is 1/4, and you're given this. But what you want to find is you want to find the sine of theta over 2. So you would start the problem like this. If you want to find the sine of theta over 2, you need to use the identity. So the identity is plus or minus square root of 1 minus cosine theta. And notice you were given the cosine theta on this all over 2. So that's what we got to reason out. Okay, now, a couple of things is, of course, you're going to have to figure this quadrant out, and that's a fairly significant part of this problem that you got to figure out. And you also have the cosecant of theta is greater than 0. That'll help you to figure this out as well. So one thing that you want to do on this is, if you just look at this piece right here, if you look at the fact that the cosine is equal to 1 over 4, that's given x and it's given y, and it's given, it's given r. So it's given x over r, so it's given a positive value of x. And it's given a positive value of 4. So what this is going to mean then, if you look at this problem, there's actually 2 places where the cosine is positive 1/4. One place would be here in quadrant 1, the other place would be in quadrant 4. So if you just looked at like a reference triangle here to kind of help you understand this, is you could have an x value of 1, an r value of 4, and then a y value that would come from the Pythagorean Theorem. Actually, if you did the Pythagorean Theorem, that would just be 16 minus 1, or that would be square root of 15. But you could also be in this quadrant, because you'd still have x equals 1, you'd still have r is 4, but now y would be negative root 15. But what it says is it also gives you this. The cosecant is positive, so that means that y is positive, so it means that you would be in quadrant 1. Okay, that's how you reason that out. So now you know that you have a quadrant 1 angle, so that means you have a positive answer to this problem. Okay? Because if you take a quadrant 1 angle and divide it in half, you're still in quadrant 1. So you've got to have a positive answer to this problem then. So we're finding the sine of theta over 2, and we know the cosine of theta right there is going to be positive, and then we know that that's a quadrant 1 angle based on what we just reasoned out, so it's a positive answer. So when you get the answer of the problem, you're going to have a positive answer, 1 minus, now the cosine's 1/4, so you just replace that with 1/4 over 2 and then work out the details. Okay. Now there's a couple of ways that you could do this. I think probably One way to do this is get a common denominator in the numerator if you'd like. I'm going to change this 1 to 4 over 4 minus 1/4 all over 2. Just do that. Okay, so the numerator is going to be 3/4 now, all over 2. Okay, now you can work with this in a couple of different ways if you want to. One way that you could do this is just realize that this is really the square root of 3 over 4 all divided by the square root of 2. Okay, you could look at this problem that way. That's really the square root of 3 over 2, okay, because the square root of 4 is 2. Then you could multiply by the reciprocal of this, and you would end up getting square root of 3 over 2 times 1 over root 2, which is square root of 3 over 2 root 2. Then you could rationalize the denominator. So if you multiply the top and bottom by the square root of 2, you're going to get this. You're going to get square root of 6 over 2 times square root of 4. So that's square root of 6 over 2 times 2, or 4. So that should be the final answer of that problem. Okay? Now I'm going to show you with a graphing calculator how you can kind of use this to make sense of this in some way. So I'm going to put my calculator, turn it on. I'll just put this in degree mode, I guess. Clear everything off. So if you look at this statement, cosine theta is 1/4. If you want to find theta, you could go inverse cosine of 1/4. And that actually gives you that this is a 75-degree angle. But ultimately in this problem, we were doing the sine of half of that angle. So we could go sine of, now I'm going to use the answer key. 75 is stored in this answer key, so I can go second answer divided by 2. So I'm doing the sine of half of that angle, and I'm getting that answer. Well, if you took the answer that I highlighted, which is square root of 6 over 4, they'll give the same answer. So you can make sense of this answer with a graphing calculator. So see, you have a 75-degree angle. Half of that angle still puts you in quadrant 1. Okay, let's do this next one. These problems take a little bit of thought. All right, this problem you're given two things. You're given this, you're given the angle, the quadrant your angle is, and you're finding the cosine of half the angle. So to start with, if we're going to find the cosine of theta over 2, we need to pull out that identity. So the identity for a half angle cosine is plus or minus 1 plus cosine theta all over 2. So ultimately in this problem, we need to figure out the cosine of theta. If we figure that out, we got it nailed. We also know that theta is in quadrant 4. Okay? So that's going to be a pretty important part of this problem when we figure out what that sine is. Okay? So let's go ahead and go to the side and let's try to reason everything out then. So what we have is we have the sine of theta equals negative 21 over 29. Now, from our knowledge, y is going to be negative 21, r is going to be 29. So we have y is equal to negative 21, r is going to be equal to 29. Now we're going to need to find what x is so that we can find the cosine. Okay, so we need to apply the Pythagorean Theorem to do that then. So we're going to have r squared, x squared plus y squared equals r squared. So I'll do it like that. So I'm going to have x squared plus y squared, which is negative 21 squared, equals r squared, which is 29 squared. Use the calculator a little bit. So let's see, 21 squared is 441. And 29 squared is 841. So I'm going to have x squared equals 841 minus 441. So that's going to give 400. And then if I do the square root of both sides, I'm going to get x equals plus or minus 20. But since theta is in quadrant 4, that means that x is going to be positive 20. So we got everything we need now. So what this means is when we're trying to find the cosine, the cosine of theta is going to be x over r. So x is 20, r is 29, so that's what's going to get plugged in for that cosine is that then. Okay, so what we have then, now what in the world did I just do there? Come on, stop that crap. Stop it. Okay, so what I'm going to have, oh, where'd the pen go? Shoot, now everything's screwed up again. Okay, so I think I got this thing working, maybe. Okay, that's kind of messing up. So let's see, we got 1 plus cosine. Cosine we just worked out was 20 over 29. Oh, this thing's starting to screw up again. Over 2, okay. Now one thing I want to pull up on the calculator, and I'm going to explain it this way, is in this problem, see, you're given that the sine is negative 21 over 29, but you're also given that this is in that quadrant. Come on, just do what I tell you to do, computer. Stop this crap. Okay, so if I go inverse sine of negative 21 over 29, let's get that question mark out of there. Inverse, stop it. So if I go inverse sine of negative 21 over 29, that gives me a negative angle, and that's in quadrant 4. Okay, so really, if I added 360 to this, we're looking at a 313 degree angle. Okay, now if we divide that by 2, remember we're ultimately in this problem, we're doing the cosine of half of that angle. So we're looking at the cosine. Now why did it divide by 2 twice? Okay, we're looking at 156. So this part right here is really dealing with quadrant 2. Theta's in quadrant 4, but because of the magnitude of that quadrant 4 angle, you're going to be in quadrant 2 when you divide it by 2. So that means that the cosine of a quadrant 2 angle is negative. So we're going to have a negative there. So that means we're going to have a negative answer. Okay? So what we have is we have negative square root of 1 plus 20 over 29 all over 2. Now we do have a complex fraction, so we need to deal with that. So if we want to get rid of that 29, we're going to multiply the top by 29, and we're going to multiply the bottom by 29 to get this. Now what in the world is this thing doing? Okay, let me pause. Okay, so when I multiply this out, I'm going to have 29 times 1, so I'm going to have negative square root of 29 plus 20. See, those things crossed out. And then 2 times 29 is going to be 58. So I've got that. So that looks like that's going to be a negative square root of 49 over 58. So that's negative square root of 49 over square root of 58. So that's going to be negative 7 over square root of 58. Then I can rationalize that denominator to get a final result. Okay, so the final answer of this problem should be negative 7 root 58 all over 58. Okay, now let's look at the calculator and let's see if we can kind of reason out maybe why this is the right answer. Okay, I like to get students to do this because it's kind of helpful. So you can go second sine, inverse sine of negative 21 over 29. That'll give you the angle. Okay, now we could go ahead and chop it in half if we want to. I think I'm going to go ahead and just add 360 to it like this. Then I'm going to divide that by 2. Like, what did I just do? What did I just do? Come on, stop this crap, calculator. Let's try again. So let's go inverse sine of negative 21 over 29. Let's get that answer. Okay, let's add 360 to it. And then that'll give the quadrant 4 angle. Okay, now let's divide it by 2. Or actually, let's just do this. We're doing the cosine of theta over 2. So let's go cosine of the answer over 2. Okay, let's see what that's doing. It's taking 313 and dividing it by 2. And it gives you the negative answer that we got. Now, our answer, let's check it. So our answer is negative 7 times the square root of 58, all divided by 58. Look at that. It's a thing of beauty. It gave us exactly the same answer. My goodness, I think I can even do that. Okay, so we're good. Okay, so that's the answer. All right. Okay, now let's move on to the next page and finish up with a couple of more things here. Okay, this problem right here, you have to kind of look at a certain way, and I had written down on here a hint that we want to do the tangent double angle identity. And the reason for that is it looks like we have two of the same angles right there. So ultimately, in this problem, we got two triangles. They've given us a couple of things. They've given us the base of this triangle right here. What is going on with this computer? It keeps screwing up again. Okay, so anyway, if we do this, it looks like they gave us this side. Stop this computer. I didn't do that. This side right here is 3. This is 9. And ultimately, we're going to find the exact value of CD. So let's just call this X. And we're going to look for this part of the triangle in this figure. And we're going to have to use some trigonometric identities to figure that out. Well, the first thing that I see in this problem, and you may see as well, is we have a right triangle that I'm just going to highlight right there. And we have enough information to write a trig function on that. So if we go the tangent of this angle, which is given by alpha over 2, that's going to be opposite, which is 3, over adjacent, which is 9. So we get tangent of alpha over 2 is equal to 1/3. Okay, so we have that. Now, what we want to kind of do on this is maybe use a double angle identity, because if we double these two angles, we may end up, we're going to end up with this whole angle right here. So notice that the tangent 2x identity goes like this. That's the one that says 2 tangent of x all over 1 minus tangent squared x. Okay, so let's do that. Now what we're going to end up doing on this is we can double this angle right here. So what we can do is we could write this, we're just going to substitute in for x that alpha over 2. Okay, so we're going to go ahead and do that. Okay, so I'm going to replace, make a couple of little substitutions in here. I think this thing somehow got erased. That was 1/3. Okay. So I'm going to do a couple of substitutions on here. So I'm going to substitute in for x alpha over 2. Okay, and where I'm going with this, I think you'll see, is I have the tangent of twice alpha over 2 is equal to 2 times the tangent of alpha over 2 all over 1 minus tangent squared of alpha over 2. Well, those cross out, so this is going to give you what the tangent of alpha is. So if we can figure out what the tangent of alpha is, then we should be able to find what that value of x is then in the diagram. Okay, so what I'm going to have is 2 tangent alpha over 2. Now, tangent of alpha over 2 is 1/3. So this is going to give us the tangent of alpha is equal to 2 times 1/3 over 1 minus 1/3 squared. Okay, so I'm going to move this over here. So I have tangent of alpha equals, the numerator is just 2/3. Stop that crap. This thing is messing up. 2/3 over 1 minus 1/9. So I'm squaring that 1/3 to get 1/9. Okay. Now what I'm going to do on this is I'm going to go ahead and just crunch this out and get an answer on this. So I am going to multiply the top and bottom by 9 over 1. And what that's going to do is that's going to get rid of that complex fraction. So that's going to give me tangent of alpha. And notice on that 9 over 3 is 3. 2 times 3 is 6. The bottom you got 9 times 1 is 9. That crosses out. That gives 6 over 8. or 3/4. So we get the tangent of alpha is equal to 3/4. Okay, so we're down to that point. Now, if we go to our diagram, and if we now look at the entire triangle, I'm going to erase all this stuff right here so we can just look at the entire triangle, which is this whole thing right here. I got this side. Come on, don't erase. I don't want you to erase. Stop that crap. This thing just does whatever it wants to sometimes. It just drives me crazy. So we got this whole triangle. Okay, so if we do the tangent of this whole entire angle, which is alpha, we would get this. We would get tangent of alpha equals side opposite, which is x plus 3, all over the side adjacent, which is 9. Now, we just figured out that the tangent of alpha is 3/4, so we get 3/4 equals x plus 3 over 9. Now we can solve that proportion by cross multiplying, and then we have the answer to the problem. So this is going to be 3 times 9 is 27 equals 4 times x plus 3. So that is 27 equals 4x plus 12. Subtract 12 from both sides, which is going to give, what's that? 7 minus 2 is 15. 4x, and then we can divide by 4. So we get x is equal to 15 over 4 as the answer to that problem then. Okay? Now 15 over 4, if you calculate 15 over 4, that's about 3.75. One thing that a lot of times students think is they think if this is 3, if from there to there is 3, there's kind of a tendency to think that's also 3, but it isn't. It's something different, so that's 3.75. So that is an approach to the problem using the tangent to x identity is very helpful. Okay, that's a good problem. That's a really good one. Okay, let's move on and finish up these last couple of problems here. Okay, to close this thing off. Okay, so what we're going to have on this one is I'm wanting you to find the cosine of 2 theta. I'm giving you the sine of theta is this, and I'm giving you the quadrant it lies in. Okay, so what we're going to do with this is I'm going to write down these forms of the identity. So the cosine of 2 theta, you have these options. You have cosine squared theta minus sine squared theta is option 1. Then you have 2 cosine squared theta minus 1. Why is it doing that? Oh, I hate it when it just does whatever it wants to, like I keep saying. It just drives me up the wall. Okay, the other thing is 1 minus 2 sine squared theta. All I'm doing is writing with my pen, and it just starts doing all kinds of crap. Okay, so what do we want to do? I would suggest that since I gave you what the sine is, it would be very logical to use this identity, because then there's nothing to it. So all we got to do in this problem, we don't have to worry about the quadrant. The cosine of 2 theta is equal to 1 minus 2 sine squared theta. I already gave you what the sine is. It's 15 over 17, so plug it in and work it out. So you're going to have 1 minus 2 times 15 over 17 squared. Work out the arithmetic. Okay? So that's going to be 1 minus 2. I'm going to put the 2 over 1, and then I'm going to square this on my calculator. So 15 squared is 225. 17 squared is 289. Okay, I'm going to have to maybe throw my computer in the trash or something. This is really making me just aggravating the hell out of me. Come on, stop this crap. That's minus 2 over 1 times 225 over 289. So that's 1 minus, and if you multiply straight across, that's going to give 450 out of 289. Okay, we want to get a common denominator. So I'm going to write that as 289 over 289 minus 450 over 289. Okay, then I'll get an answer to the problem. So I just need to take 289 minus 450. That's equal to negative 161. So that's the answer to that problem then. Now this is a problem that you could actually interpret on your calculator. So I'll see if I can pull the calculator out. without screwing crap up here. Okay, so let's see. So what I could do is I could go inverse sine of 15 over 17. So I could actually find the angle. So it's a 61-degree angle. It's in quadrant 1. Now if I just do the cosine of double that angle, now see, I'm going to use the answer key because the 61 is stored. That'll give me that. Now if I take my answer, negative 161, stop that, divided by 289, I get the same answer. So you can check on your calculator with this problem. Okay, one last problem. Let's hope this thing doesn't screw up anymore. I'll probably have to reboot my computer to fix whatever's going on this. Okay, so this one we're going to do the sine of 2 theta. The identity for that is 2 sine theta cosine theta. Okay, so basically in this problem I gave you that the cosine of theta is equal to 24 over 25. That means that I've given you x and I've given you r. And I've also given you that you're in quadrant 4. Okay, so if we did a little diagram on this, this is kind of what would be going on this problem. Oh, come on. Now it erased what I just drew. Piece of crap. Okay, here's my thing again. Okay, we're in quadrant 4. We have some sort of an angle in quadrant 4. The point that we have, if we draw a reference triangle, we have x is equal to 24. We have r is 25. So we need to find y by the Pythagorean Theorem. So we have x squared plus y squared is equal to r squared. So we have 24 squared plus y squared equals 25 squared. So 24 squared is 576 plus y squared. 25 squared is 625. Subtract from both sides, you're going to get 625. So you get y squared equals 625 minus 576. Okay, I think that gives y squared is equal to 49, I think. Yep. Okay, so square root both sides, we're going to have plus or minus 7. Now, since we're in quadrant 4, then we know that y is negative. Okay, so here's what we do to finish up. If we want to find the sine of theta, the sine of theta is y over r. So that is going to be negative 7 over 25. The cosine is going to be x over r. So that's 24 over 25. So now we just need to multiply everything out, and then we got an answer to the problem. So I'm going to put the 2 over 1. I take 2 times 7 times 24. I'm going to get negative 336. And then 25 times 25 is 625. So that should be the answer. Okay. Circle the thing. Let's try to highlight it. God, this drives me crazy. This thing just goes nuts sometimes. Okay. So now let's do this. I'm going to have to reboot the computer after this is over and fix this crap. Okay, so here's how you can tell you're right. So you go second cosine of 24 over 25 to get the angle. Shoot. This is getting comical. Okay, second cosine of 24 over 25. It's the sensitivity of this pen, of this touch screen that's messed up. So that's 16 degrees. Now, if I do the sine of twice that angle, I get this answer. Okay? Now, let's make sure. Now, we have a quad. Now, the thing that I didn't do right on this, I need to do this one more time. Our angle's in quadrant 4. So if I go inverse cosine of 24 over 25, like this, I get this. But that's a quadrant 1 angle. So I need to take... that's a reference angle, so if I do 360 minus that angle, I get that angle. So our angle is actually 343.7 degrees. So now I wanted to find the sine of twice the angle, so I say sine of twice the angle And it gives me this. So notice I got a negative answer. So if I do negative 336 divided by 625, okay, I get the same answer. Okay, so checked. All right, so that's the end of it. Hallelujah. Now I got to fix my computer and see what the heck's going on. All right. So hope this helps you to learn everything well.